the n equals 1 to n equals 2 absorption frequency for a certain particle, we don't know its mass, let's just call it n, in a certain one-dimensional box, still dealing with one-dimensional particle in the box. The frequency is given to be 6 times 10 to the power 12 per second. Now we are asked to find the frequency that corresponds to absorption energy when the particle absorbs energy and moves from state 2 to state 3. So here what we can do is, let's first write the energy that corresponds to this transition. Right, that is going to be, okay, it's going to be h mu. We definitely know the energy for this, but we can also write it as E1 minus E2, the absolute magnitude of that, because frequency cannot be negative, and the value of E1 minus E2, sorry, we don't need to do E1 minus E2, we can actually just do E2 minus E1, never mind that. So H times this nu is equal, I'm gonna call it nu 1 to 2. It's gonna be 2 squared is 4, 8 squared over 8 ml squared minus 1, 8 squared over 8 ml squared, which is 3, 8 squared over 8 ml squared, right? So we need to find the frequency for a transition from 2 to 3, absorption from 2 to 3, and that will be, I'm gonna call it this, and it's going to be 3 squared, which is 9, 8 squared over 8 ml squared, minus 2 squared of 4, 8 squared over 8 ml squared. Now that is going to be 5, 8 squared over 8 ml squared. So what I can do is, if I call this equation 1 and if I call this equation 2, I'm just going to divide equations 1 and 2. That will give me h nu 1 to 2 or h nu 2 to 3 be 3/8 squared over 8 ml squared times 5/8 squared over 8 ml squared. This gets cancelled, 8 squared gets cancelled. H gets cancelled. So this will give me nu 2 to 3 to be equal to nu 1 to 2 times 5 over 3. And I know nu 1 to 2 is 6 times 10 to the 12 seconds. So nu 2 to 3 is going to be 3 1s and 3 2s. So 5 2s are 10, it's going to be 10 to the power 13 per second. So this is the answer.